Hello everyone, welcome back to the channel. Today we will be discussing an Olympiad level problem. This was asked by Victor. He's a maths enthusiast. So let's see the problem. Determine the largest number, that is the product of positive integers whose sum is 1976. So let's say the integers are from x1, x2, x3 to xn. By the way, if you would like to give this problem a try, then pause the video. It's a very interesting problem. Otherwise, continue watching for the solution. So we have divided the number 1976 into positive integers x1 to xn. Therefore, what is the value? Like I equals to 1 to n. Summation of xi is equals to 1976, right? And each of xi is greater than equals to, not greater than equals to, actually greater than 0, since we have positive integers, right? And we need to maximize the product, right? Now we can take xi as any integer from 1, 2, 3 till 1976, right? If we take 1976, then the product of 1976 itself is 1976, right? If we take 1 and 1975, the product is 1975, right? 1 into 1975. So basically, we have to keep the sum as 1976, okay? So let's consider a general case first. Let's say we have been given a number n. We divide it into 3 and n minus 3, okay? Now, in which cases would it be greater than n itself? Let's find those cases. This would be 3n minus 9 greater than n, 2n greater than 9, and greater than 4.5, and greater than equals to 5. I just took the ceiling of 4.5, right? So if we take any integer which is greater than equals to 5, dividing it into 3 and n minus 3 would always make the product larger, right? Since 3 into n minus 3 is greater than n, right? We just found out when does this condition hold, that is n greater than equals to 5. So we don't need to consider any integers from 5 to 1976 in our product, right? What does that leave us with? 1, 2, 3, and 4. We need to consider this. These are the values that xi can take. We can also remove 4. Why? 2 plus 2 is equals to 4, right? And 2 into 2 is also equals to 4. So if the summation is 4, then we can get product as 4 from 2, right? This is a maximum product for 4, by the way. You can try, otherwise it's 1, 3, okay, and 4, 1. This is 1, 3 or just 4, not 4, 1. So this would be 3, 1 into 3, and just 4 would be 4. So maximum is the 4, okay? So we can remove 4. We can also remove 1. How? If we consider number 1, n would always be greater than 1 into n minus 1 if we split it into two numbers, out of which one is 1, okay? This leaves us with only 2 and 3, right? Now consider 6. If you split it into twos, how many twos will you get? 2, 2, and 2, 3, right? If you split it into 3, how many threes will you get? Only 2. But which is greater? This is 8, this is 9. So splitting it into 3 cross 3 is greater, right? So if we take a number and divide it into steps of 6, it's always better to split it into 3, right? This means 3 has a higher precedence than 2 when splitting the numbers, right? To maximize the product. Now, for general, let's consider a number whose sum is 3 times k, right? So what will be the maximum value for this of product? The number sum of number is 3 into k. So we can write it as 3 plus 3 plus 3 dot dot k times, right? So this is the sum. For the product would be the maximum product, it would be 3 raised to power k, right? So this was a general case where the number was divisible by 3, but it can also have remainder 1 and 2. In case of the remainder is 2, we can directly multiply it 2 cross 3 raised to power k, right? Where the number is 3 into k plus 2, the sum of the number is. Okay. What about the case where remainder is 1? If the remainder is 1, we know that it's always better to add 1 instead of splitting it into 1, right? Where we got this case. So if the number is like 3k plus 1, the sum, we can write it as 3k minus 1 into 3 plus 1. Okay. Now consider 1976. If you divide it by 3, you will get 3 into 658 plus remainder as 2. So what will be the answer from this? It would be 2 into 3 raised to the power 658. Okay. If you have any doubts, do leave a comment. Thank you.